Assalamualaikum and hello everyone. Welcome to the video for 5.2 Alkene, where in this video we will continue to learn to outline the mechanism in dehydration of alcohol. So this is the third and the last one for the video for the mechanism for the dehydration of alcohol, which on your notes it will be on page 20. Okay. So previously we have learned about the dehydration of alcohol, where the removal of water molecule. So when there's actually the removal of molecules, so this is elimination reaction. Okay, for the case of alcohol, we're going to remove OH and we will remove hydrogen as well. Okay, for the removal of hydrogen, hydrogen too must be the hydrogen attached to carbon next to the carbon containing OH group. But then we have to consider the classification of the carbon or the hydrogen itself, tertiary, secondary, primary. Okay, to determine the major or minor product. Okay, so mostly we have looked for the reaction. It's just that the last video, the second video, we have learned about rearrangement. This is something new. Okay, so for the rearrangement, and this example also, we're going to look at the rearrangement as well. A different type of rearrangement. Okay, so from this reaction, we have 3,3-dimethyl butanol. So again, we have four carbon, and carbon number 2 we have OH. However, on carbon number 3 we have dimethyl. So dimethyl. So this is actually the reaction lah, the structural formula of it. Okay, so what we're gonna remove here again for the dehydration of alcohol, we're gonna remove OH. Right, we remove OH. Next, we're going to remove hydrogen from the carbon next to it. So when we look on our left hand side, this is actually our primary carbon. So this is actually our primary carbon. And on our right hand side here, this carbon attached to 1, 2, 3, 4. Ada 4 carbon. So dia adalah quaternary carbon. However, for quaternary carbon, it means that on the carbon itself there is no hydrogen. Okay, so from this equation itself, kita tengok the possibility for the answer is only 1. Kan? Sebab when we can only remove the hydrogen from primary, we have to remove the hydrogen tu must be next to the COH. So in this case, we remove the OH, we remove the hydrogen. Okay, so we remove the bond. Okay, then we're going to substitute it with our double bond. So this is our alkene. But then again, so this is actually based upon our reaction equation. Sometimes the way to see it is actually you have to do the mechanism itself lah. So let's do the mechanism together then. Okay, so first step for the protonation of alcohol. Yang this one I believe Miss boleh laju sikit sebab yang ini pun kita dah tengok quite a lot of the reaction itself. If you're a bit unsure, boleh tengok balik lah. The first video ever tu and the second video I have explained for the step 1 and step 2. Okay, so for the step 2, formation of carbocation ion tu, once you remove the H2O, you have to check the classification of the carbocation ion and the carbon yang bodyguard dia on the right hand side and the left hand side. So let's do the classification. Here is primary, here is my secondary, here is my quaternary. Okay, so macam mana ni? Previously, sebab next to it is actually the tertiary one kan. So senang lah kita nak tahu we're gonna shift 1 to hydride shift. So it means that we shift the carbocation ion as well as the hydrogen. Tapi this case around, next to it is quaternary. But actually, carbocation ion, there's only the tertiary, secondary and primary only. So what happens is that we will shift the carbocation ion. In this case, this one, is there any hydrogen to be shifted? There's none kan? So what would happen is that the positive charge still akan shift juga, tapi dia akan shift dengan apa? Dia akan shift with our methyl. with our CH3 here. So what will happen is that for our product here, dia akan jadi macam ni lah. So what happen? Again, ni kita padam balik. Padam semua yang classification tu. Okay, so what happen next is actually we have to swap this position. So when we swap this position, it means the positive yang dekat sini. This one is the one where we have our CH3. Okay, dalam case ni, what is the name of the process itself? Sebab sekarang ni, previously we learn 1,2 hydride shift kan. So it means that the shift tu between carbon here dengan here ni, bertukar carbocation dengan hydrogen. In this case, actually, what we're shifting is actually CH3. So we have to write down 1, 2, CH3 shift. So for our syllabus, we will only learn 1, 2 position, 1, 2 hydride shift, and 1, 2 CH3 shift. Itu sahaja for our syllabus. So 1, 2 CH3 shift here. So what happened here? Now we need to classify it again. Betul tak? Does it form the most stable carbocation? So here is actually this one, our carbocation itself attached to 1, 2, 3. So this is actually tertiary carbocation. Next to it, carbon ni kan, got 1, 2, 3. Ni pun tertiary carbocation juga. Tertiary carbon juga. But it's fine. Okay, yang sebelah dekat sini masih lagi primary. Okay, next to the carbocation itself lah. Okay, so this is the most important part. This one, actually what we want for the rearrangement ni, we want to increase the stability of carbocation. Kalau boleh dia nak lagi banyak sugar daddy dia kan. Nak lagi, it wants to be a tertiary lah. Mak tertiary ni ada 3 sugar daddy ataupun 3 alkyl group attached to it. Okay, so in this case, around kita tengok. So this is the most stable one. Tak kisah, yang paling penting yang carbocation kita lah. Yang the one sebelah pun tertiary, nice lah. So it's very, so this is our stable compound lah for the carbocation. Okay, so for the step 3, we're not going to take this one. We will take this molecule itself. This will be our step 3. Okay, so when we take this is a step 3. So deprotonation of hydrogen, deprotonation of our complex ni, we're going to take the hydrogen. Okay, so take the hydrogen. Next, we have to remove the hydrogen too. It's not from our carbocation. We have to remove the hydrogen from the carbon next to the carbocation itself lah. So it's either on your right hand side ni, primary or tertiary, which is your left hand side. So again, we have to consider yang major minor. Even though the equation ni nampak macam mana ada pun, tak ada pun. Okay, so sebab tu lah actually for the dehydration of alcohol, the most sebenarnya we have to know lah a bit of the mechanism itself. Okay, so that later during the mechanism tu barulah kamu nampak actually ada the product, the major product. Okay, so here what we're gonna take, we're gonna take it again from our first step tu, kita ada osoh kita kan. So osoh ni is negatively charged. So again, which hydrogen will be osoh take to form hosoh back? So osoh ni, we prefer to take the tertiary ni lah, to form our major product. So for the mechanism ni, we want our major product. Okay? So that is actually the mechanism for deprotonation of alcohol. Okay, so again we have to hosoh H2SO4 pun accepted. Okay, this one, make sure the deprotonation ni, it must be remove hydrogen from next to it lah. From hydrogen from next to the carbocation itself. Okay, so this is actually the product. Okay, so this is actually, we have seen for the rearrangement. Rearrangement can occur 1, 2 hydride shift as well as 1, 2 CH3 shift. So it is very important. Okay, the next step, later when we see formation of carbocation je, we have to see the rearrangement. Yang protonation and deprotonation is still the same thing. Protonation ni, our alcohol react with our hosoh to form yang H2O positif dengan osoh negatif kita. The dual protonation ni, the same osoh will react with our carbocation ion to take the hydrogen, then we're going to form our alkene. Okay, yang ini, if you're not sure about the arrow ni, check lagi sekali. Okay, so that's for the case of 3,3-dimethyl butan 2-ol. Okay, so the last mechanism that we're going to look at for the dehydration of alcohol is the reaction 2-methyl butan 2-ol. So 1, 2, 3, 4. On the same carbon we have our OH, and the same carbon we have our CH3. Okay, so let's look here based upon the reaction equation first. Okay, so what we're going to remove, again, dehydration, we're going to remove water. First step, remove OH, which is this one. Next, check from the carbon next to it. Bodyguard kanan dengan kiri. On the right hand side here, we have actually a secondary carbon. On left hand side is primary. Okay, kan secondary ni because it attached to 1, 2 carbon. Primary ni because it attached only to 1 carbon lah. Okay, so first possibility, it's actually because we have 2 different classes, so it means that we have 2 different product lah. Okay, so for this one, what we have is actually the removal of OH and the removal of the secondary hydrogen. So here we're going to form our major product. Okay, next possibility is actually when remove the OH as well as we remove the hydrogen itself. Okay, so remove the OH, remove the hydrogen. Okay, so what we're going to do is actually this one, remove the OH and remove the hydrogen from primary. So we remove lah the bond. Okay, so when we removing the atom itself, we're going to add our double bond here lah, so that our carbon contain 4 bond. So again, this is our major product. This one is our minor product. Okay, so this is actually based upon the equation. So let's do the mechanism itself. Do we get this one or not? Okay, so again, for step 1 dengan step 2, it's the same as previous one. So yang ini Miss boleh speed up sikit lah. Later we're going to check whether this reaction, is there any rearrangement occurring. So for the formation of carbocation ion here, so right now, once we have removed the water, let's check the classification of the carbocation ion and the carbon next to it. Boleh tak stable lagi? Remember the order of stability is tertiary more stable than secondary, secondary more stable than primary. Okay, so let's do here. So here at the end here is primary. Carbocation ion itself, attached to it 1, 2, 3. So here we have our tertiary carbocation ion. Next to it is attached to 1, 2. So secondary carbocation ion, secondary carbon. So does it need rearrangement? Perlu ke tidak? Because this case, because the carbocation ion itself is the most stable one. Dah memang paling stabil lah. So there's no need to do the rearrangement. So we can do the step 3 where we're gonna take the osoh ni, we'll take one of the hydrogen. Okay, so we're gonna take the product. We're still gonna take the product from the step 2. Okay, this case, osoh ni will take hydrogen, but it will not take hydrogen from our carbocation ion lah. It will take the hydrogen next to the carbocation ion tu. So next to the carbocation ion, there's a possibility of secondary and possibility of primary. So again, for mechanism, we want the major, which is our yang secondary kita lah. Sama pula tu. Yay! Kali ni sama dengan reaction equation. Okay, so this one, we're going to take the hydrogen from secondary. So that is the last step for the mechanism. Okay, so we have looked, there's quite a lot of example for the dehydration of alcohol. So again, it's completely new kan. Yang ni adalah full headed arrow, the rich electron, the poor electron. There's 3 steps. So again, there are 3 video for this dehydration. So a bit yang mana tak sure boleh tengok lagi sekali lah, especially for the part of rearrangement. So that's it, the last video for the dehydration of alcohol.